Find all real solutions of this equation. Negative 10x cubed plus 15x squared plus 16x minus 12 equals 0. In other words, we're trying to find the zeros of this polynomial. We can use the rational zeros test or rational zeros theorem. The factors of 12 are positive or negative 1, 2, 3, 4, 6, and 12. We also divide by the possible factors of negative 10, which are positive or negative 1, 2, 5, and 10. There are a lot of possibilities here. When we divide, we can take each of these things divided by 1, each of these things divided by 2, each of these things divided by 5, each of these things divided by 10. There's a lot of possibilities there. And so instead of going through and just testing blindly, we're going to use our technology tools to give us an idea of what a good guess might be. So we're going to just graph this, and that'll give us an idea of what might be some zeros. So we're going to go ahead and add a graph and just type this polynomial in. So negative 10x cubed plus 15x squared plus 16x minus 12. Okay, and we're just going to call this peeking at the graph. We're just peeking at the graph to see what might be a 0. So we see where it's crossing the axis. Those are the zeros. I'm going to go ahead and zoom in on those just to get a better idea of what's going on here. So we'll just zoom in on those. So I've got here, looks like right here, okay, we don't know really what that is, but, and actually let's go ahead and change this to a whole number so that it's a little bit easier to kind of see. So over at 4, I see that I've got a 0 like about halfway between. So that might be 2 right there. Okay, and so we're going to test 2. Let's just see if that works out. All right. So, and 2, of course, is in this list, 2 divided by 1. So we'll test 2 out. We've got negative 10, 15, 16, and negative 12. So bring the negative 10 down. Negative 10 times 2 is negative 20. We add these and we get negative 5. Negative 5 times 2 is negative 10. 16 plus negative 10 is 6. 6 times 2 is 12. And look at that, we add those, we get 0. So it worked out for us. So by peeking at the graph, we were able to make a good guess as to what we should pick here, what we should try out. And that'll save us some time because we don't want to go through and test all these different possibilities here. There's 32 possible numbers here that we would need to check. So now that we've got 2, what we've just found is that this factors as x minus 2 times, and then this thing here, negative 10x squared minus 5x plus 6. And now we're setting this equal to 0. Now we have a quadratic here, and we could try to factor that just by using our techniques of factoring quadratics. So I'm going to kind of gloss over that part because I think we know how to go about doing that. And this quadratic ends up that doesn't really factor nicely, so we're going to use the quadratic formula. Okay, our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And now we go ahead and just plug all that in. Let's do it over here. So negative b is 5 plus or minus the square root of negative 5 squared minus 4 times negative 10 times 6 over 2 times negative 10. So we have 5 plus or minus the square root. We've got 25 and then plus 240. And so this is 265. So 265. And that's all over negative 20. And now, well, we've got these 2 solutions. Okay, 5 plus the square root of 265 over negative 20, and the 5 minus square root of 65 over negative 20. And of course, these are not rational numbers because you've got this square root, and that's not a nice perfect square. And so these were not even in the list here. But we've got these two solutions. These are real solutions, okay? And if we'd like, we can plug these into the calculator, and we would get our two other answers. We'd get x equals negative 1.0639 approximately, and x equals approximately 0.5639. So those are the two other real zeros. So all of our zeros are x equals 2, and those other two. Those are all our real zeros.